Okay, so this is 4.3, number 47. We're going to just get this one started because it looks pretty intimidating. It's not too bad though. So we want to find critical numbers, and once you have critical numbers, you can set up your interval and start finding increasing and decreasing by testing points in your interval in the first derivative. To find the derivative, f prime of x, we can let the 4 go along for the ride. It's a constant factor. And the derivative of the first term now is 1. And we need the derivative of arcsine x. So that one, the derivative with respect to x of arcsine u, this is a formula, is equal to, let me see, I'm looking it up in my book here, u prime over square root of 1 minus u squared. So our u is just x. So in the formula where we see u, we'll put x. And then the u prime is just 1. So we don't even have to worry about that except to put a 1 up there. So we have then, for this derivative, 1 minus 1 over square root of 1 minus x squared. And now we're going to set the derivative equal to 0, find out where the first derivative does not exist. So we're going to have places where the first derivative does not exist is where you zero out the denominator, and we can make this all into one fraction, so that we'll multiply the 4 in, might as well. 4 minus 4 over square root of 1 minus x squared. And then we'll multiply the first term by square root of 1 minus x squared over square root of 1 minus x squared to get a common denominator. So that's being multiplied. And that gives me 4 square root of 1 minus x squared minus 4 over a common denominator, square root of 1 minus x squared. We're moving up. We're going to set this equal to 0. And we're going to set the denominator equal to 0. So numerator and denominator separately. For the numerator, 4 square root of 1 minus x squared minus 4 equals 0. We'll factor that. We can take out a 4. And then we'll set what's in the parentheses equal to 0. So I'm moving up. Square root of 1 minus x squared equals 1 when I move the 1 over. Square both sides. Subtract 1 from both sides. Divide by negative 1 on both sides. And x is equal to 0. Critical number. The denominator, we'll set that equal to 0. Square root of 1 minus x squared equals 0. Square both sides. Add x squared to both sides. Square root both sides. And careful, careful, careful here. You're getting a positive and a negative. So you're going, I'm sorry, wrong side. Not that it matters because it works out either way, but you're more used to seeing it that way. So x on the right is equal to positive 1, and also x is equal to negative 1. 2 answers. And these are also critical numbers. So when you set up your interval, you're going to have negative 1, 0, and 1. And I need to look back and make sure these really are critical numbers, because it looks like actually I'm going too fast, and it's easy to do that. So 0 is a critical number. I'm looking right back at, oh, nope, I was looking at the wrong place. So I'm looking here. And so we are okay. So they are all critical numbers. I have to make sure that if I plug it the value into the original equation, it is part of the original equation. So it's part of the domain. It doesn't like zero out a denominator. So your intervals that you're checking are from negative infinity to -1, from -1 to 0, from 0 to 1, and from 1 to infinity. And you're going to take test values in there. So -1.5 maybe, -0.5, 0.5, and 2. Whatever, any values that are in the interval. And you want to find out if the first derivative is positive, because then that interval is increasing for the original function. Or find out if the first derivative is negative, because then the original function is decreasing on that interval. Okay, so hopefully this got you started.